All right, you're here, I'm here. Let's begin. So we are starting our fifth unit today. Now, just a little, because we're two classes in one, you could argue for the people in the 3U course that every unit so far has had a significant portion of it was a review of stuff you've learned earlier. It's like last unit, you guys did learn some new stuff, but you reviewed sine law and cosine law while the 3M people were learning it. Our first few units with quadratic functions, every unit we did something where you guys did a great time. So this is the first unit where everything is new for everybody. So it's good that you're here, but you really want to dial in. Don't take your foot off the gas pedal or put it back on the gas pedal. But yeah, brand new stuff. Now that said, the first page of today's lesson is kind of catching the 3M people up to speed on one lesson you guys did last unit. But yeah, let's dive in. It's a bit of a beefier lesson. Lots of visuals though. That's why that your lesson sheet is kind of feels big. It should go by okay though. But yeah, it is a bit beefier. So let's talk about the unit circle in the CAST rule. So up until this point, you guys are used to working with angles in triangles. So between 0 and 180 degrees. But in real life, angles can go beyond 180 degrees. You guys know, like, I don't snowboard or skateboard or anything, but like in the context of those, like what's a 360? Where you do one complete revolution, right? And then 720 is like a type of trick, right? 720 is when you do two full spins. Am I right? I think I'm right, yeah. And then hashtag N64, 1080 snowboarding. Anybody play? That's a few generations of Nintendo before you guys were born. Anyway, any of you guys grew up on an N64? What's the first Nintendo system you guys? The Wii was your first, like, you could just start walking and then you put a Wii nunchuck in your hand. Okay. Anyway, before the Wii, there was the N64. Anyway, 1080 snowboarding. 1080 is 3 revolutions in a row. But in a more serious note, if I wanted to describe a position of a aircraft, I'm going to need more than 180 degrees. 180 degrees would get me from here to here. If I was describing like a top-down view of an aircraft, we need to expand our horizons beyond just triangles and talking about angles. And that's what we're doing today. We're going to talk about angles bigger than 90, bigger than 180, and talk about their sine, their cosine, and their tan, which is kind of a weird thing to think about if all you've done is work with triangles so far. So how are they calculated? First things first, some new terminology. This first little bit is a bit conceptual. To answer these questions, the first thing we need to talk about is called the unit circle. So everybody knows what a circle is. What is the unit circle? I got 3 little bullet points for us here. So the unit circle is a circle on the Cartesian plane. Okay, so a lot of people have come in late. Does anyone need a lesson sheet? This is where you would speak up if you need one. Okay, so a circle on the Cartesian plane. And not just any old circle. The center of the circle is at the point 0, 0. And the radius is 1. Hence the name unit circle, its radius is 1. And so on that diagram below is a diagram of our unit circle on the Cartesian plane And we can see it kind of breaks the Cartesian plane up into 4 quadrants. So a few talking points and a few things we're going to add to our diagram here. So the first thing I want to point out is the unit circle goes through kind of 4 special points. So if we have a circle on the Cartesian plane, its center is 0, 0, and its radius is 1, would you guys agree that it goes to the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1? Does that make sense? The radius is 1. So I think we can add those points onto our diagram without making it too clunky just yet. I think it's worthwhile just adding those in. These are points on the unit circle. The unit circle has many more points it passes through, but those are some key ones. All right. Now, how do we expand our idea of angles past 180 degrees in triangles? So the grade 11 U people, you saw this idea in a lesson last unit. We're taking it farther immediately today. To talk about angles in the Cartesian plane on the unit circle, we're going to think about the example I used was like in that lesson was like a movie flipboard where it like rotates up like this. So you guys can imagine the initial arm of our angle being the positive x-axis, and then our terminal arm where the angle ends, just rotating around and around and around, and then it can keep going. It can go past 180. So on your diagram here, we're going to label a few angles in what we call standard position. So the positive x-axis would be like 0 degrees. The angle isn't rotated at all. It's rotated 0 degrees. So I'm going to pop a 0 degrees on here. I'm going to just use maybe a deep purple. I'm just going to put 0 degrees right there. And if you kept rotating and kept rotating and kept rotating, when you get to the positive y-axis, maybe somebody from the 3M course perhaps, what angle would the positive y-axis represent? 3 people saw this already. Rotate up to the positive. Okay, Madeline, use 90. So we can represent 90 degrees at the tippy top of this unit circle here, the positive y-axis. If you keep rotating to the negative side, the negative x-axis, you'd have 180 degrees. And this is where the 3 people stopped, because last unit, we were dealing with triangles. We didn't have any purpose of talking about angles past 180. But now we're going to keep going. You guys can imagine rotating, rotating, rotating. What angle would you be at when you get to the bottom, the negative y-axis here? 270. That's right. 270. And if you got all the way back and did a full revolution, what would you be back at? 360. And we can hit all these angles in between. Now, I'm not going to jot this down. You guys can see it already on your graph. But certain angles have certain special points on the unit circle, right? 0 degrees, 1, 0, 90 degrees, 0, 1, 180 degrees, minus 1, 0, 270 degrees, 0, minus 1. Today, we're going to be connecting these points, these coordinates, these numbers with the angle in a very special way. One thing I want to add to these diagrams here, I think this is the last thing I want to add. No, there might be a couple more things. First thing is we always rotate our angles, for now, counterclockwise. Counterclockwise. You know what? Miss Plattner would be mortified right now. I didn't even leave myself room to write clock. I gotta rewrite that out. Counterclockwise rotation. Counterclockwise rotation. You guys are familiar with clockwise, counterclockwise? I know, can you guys read analog clocks? So like the second hand goes like clockwise, counterclockwise is the other way. So positive x-axis up, so it's counterclockwise rotation. I kid. I only kid because I love. All right. And I think we're going to begin. So we've established we can talk about angles on the Cartesian plane. We start at the positive x-axis, that's 0, and we can rotate all, and we can keep going and going and going, but it's counterclockwise. Anything you guys want to talk about? Should also this is labeled here. Should also mention 4 quadrants: first, second, third, fourth. Why do we call this one the first one? Because that's how our angles rotate. We rotate through this one first, this one second, and so on and so forth. Okay, let's continue. Let's make a connection here, or try to start making connections between the unit circle's points and angles. So you guys already know these special points. 0 degrees, this is 1, 0. 90 degrees, 0, 1, etc., etc. But what point on the unit circle corresponds to an angle of 45 degrees? Well, we can figure that out. I'll show you guys how. We got a lot of space for this. I'm going to first kind of draw this out on my diagram. So where is that approximately? Now I'm going to use my straight line tool. Why not? You guys can do your best impression of a straight line. But 45 degrees pretty much breaks that quadrant in half, something like so. I think that's probably good enough. And our question is, I want my drawing tool. Our question is, what point does that correspond to? What's the x value and what's the y value for this angle of 45 degrees? Would you guys agree? At the very least, the x value and the y value will be positive, right? Because we're in that first quadrant. Okay. And if it's 45 degrees and it's perfectly in half, they probably should be the same value as well. But let's actually calculate what those are. And we're going to do that by making a right angle triangle and using our trigonometry skills. So can you guys do this with me? Can you guys drop a little dashed line down here like this? We're going to make a little right angle triangle. And we actually know a side length in this triangle. If this is the unit circle, what's the length of the hypotenuse? If it's you guys flash me a finger. Careful which one. It's the unit circle. Its radius is 1. That means the hypotenuse is 1. It's a unit circle. Our goal is to find what is this vertical side, because that will tell us the y value of the point. And what is this horizontal side? I'll tuck it in down here, because that will tell us the x value of the point. So this is basically just a SOHCAHTOA problem. If I gave you guys this on your unit test, you'd all be happy. We're just finding 2 sides using SOHCAHTOA, but that'll tell us where this point is located. Let's do that work over to the side. Nothing too crazy here. We're just going to be using SOHCAHTOA. So let's start off by finding the x. Okay, so we're going to I'm going to show a lot of work here. You can shave off a step or two, but for the purpose of our note, I'm just going to show a ton of work. Our angle here is 45. So cosine of 45 degrees. The x is the adjacent side, and the hypotenuse is 1. So actually, we just get the x value pretty quick. The x value is just 1 times cosine of 45. And let's get our calculators. Let's just find approximately what that decimal value is. 1 times cosine 45. I'll just go to 3 decimal places, I think. But I got 0.707. About. Did you guys get that too? About 0.707. Now that we have 2 sides, let's find the third using SOHCAHTOA. So if a squared plus b squared equals c squared, then if we want to find that third side, we're just rearranging the Pythagorean theorem. And our third side we want is the y. So we're going to take the hypotenuse, which is 1, and subtract the other leg, which we now know is about 0.707. about. I'm showing a lot of steps here. Let's even get the decimal value for what that is. 1 minus 0.707 squared. About 0.5002. And then when you square root that, what do we get? We said before it should be positive. And since 45 is kind of half of 90, it should give the same value, right? When you square root that? Yeah, it does. 0.707. Do you guys get that too? We now have the point, the special point on the unit circle that corresponds to 45 degrees. We had to work a little bit for it. Later, we're going to see that we can actually get those points really quick, but we had to work a little bit for now using the skills we have. So let's wrap this up. I'm going to add this little blurb. Since x and y are positive, in this quadrant 1, and use Roman numerals there, the point is 0.707 is the x, and 0.707 is the y. That is the point on the unit circle that corresponds to 45 degrees. We had to work a little bit, but I pinky swear promise you we'll do one more. Do we do one more or two more? I don't want to promise you something I can't follow through on. We're going to do two more. And after those two more, we're going to have a quick and efficient way, a nice connection between points on the unit circle and the angle. But we're not there yet. Let's do another one. Same idea though. What point on the unit circle corresponds to an angle of 150 degrees? So 90 is here, 180 is here. Would you guys agree 150? Somewhere in here, right? Somewhere in here. So let's just draw roughly where that is. Now 150 is closer to 180. So I will kind of maybe draw it a little bit closer to 180. So something like that. Don't know why I drew an arrow. And if we repeat the drill and drop a dashed line down to the x-axis, we have ourselves a triangle. And we're trying to find this point. I'll label it xy this time. That's the goal. What point on the unit circle corresponds to 150 degrees? So I have a simple question for you guys. If this angle has been rotated 150 degrees, what angle is left in our little triangle here? Nina? 30, exactly. Can we pop in 30 there? That wasn't too crazy to figure out. 30 degrees. And now the goal is the same. We're on the unit circle. So the hypotenuse is 1. It's the radius of the circle. We want to find what's the x of this point and what's the y of this point. Now, before we even start doing the SOHCAHTOA again, would you guys agree in this quadrant, our x will eventually be negative, right? And our y will be positive, right? So keep that in mind. When we're finding x and y in this triangle, it's just the length of these sides. Afterwards, when we're writing down the point, we'll make sure to write down the point as a negative x value. But now we're just going to repeat the process. We can probably show a little less work here. So the cosine of 30 is the adjacent side x over the hypotenuse 1. And so that x value, at least that horizontal distance, is just 1 times cos 30. And we'll keep a few decimal places of accuracy there. Cosine of 30, about 0.866. That's the x value. And then to get the y value, let's do what we did before. We'll take the hypotenuse squared, and we'll subtract our x value squared, 0.866. Exact same steps as before. We're just going right to the plugging in number stage, just to save a bit of time. So can you guys do that calculation? And don't forget the square roots. One squared minus 0.866 squared. I mean, it's pretty much 0.25. And when you square root 0.25, you get pretty much 0.5. You guys get that as well? So in this triangle, we are 0.866 away from the y-axis, and the vertical height is 0.5. So now we know the point. So we'll add a little blurb here. Since we are in quadrant 2, the point that corresponds to 150 is going to be negative 0.866, 0.5. Why is it negative? We're in quadrant 2, and that's where x values are negative and y values are positive. You guys okay so far? It's just SOHCAHTOA, drawing a few things out using our new convention. Let's do one more, and then I promise you this is the last one we'll do kind of the long way. What about 242 degrees? Can you guys do a few of these things without me? Can you draw where that would be on the Cartesian plane? Can you guys drop a little dashed line to the x-axis and make a right angle triangle? And then can you reason out what the acute angle is in that right angle triangle so we can do our x and O? Zero, 90, 180, 270. So we're in the third quadrant now, right? 242, probably a bit closer. Well, it's not probably. It is a bit closer to 270. So I'm going to draw mine, I don't know, somewhere around here is 270 degrees. So this all the way rotated around is 242 degrees. It'd be somewhere there. Again, our goal, what point would that correspond to? Note, in this quadrant, our x and our y will have to be negative. But what are those distances? Let's find them. So we drop a line down. We want to find x. We want to find y. Our hypotenuse is 1. Did any of you guys, any brave soul want to volunteer? Did you guys get what this angle is with the x-axis here? Anybody figure that out yet? Emily, you got it? 28. 28 is this angle. It is correct. It's this angle here. But if I want to use x as adjacent again, I got to find the other. But yeah, this is 28. That's perfectly correct. Yeah. How about this one? So if this was 180, and then we got to 242, how many extra degrees are there from 180 to 242? You can just subtract on your calculator. 60. Why am I blanking? 62, right? Yeah, 62. Which makes sense because Emily E said this is 28, and if this is 90 degrees, yeah, it should be 62. So I'm going to pop 62 degrees in here. You guys should too. I'm also going to add this little blurb about where we got that from because it's a bit less obvious than last time. Where is that 62 from when you guys are going back and studying later? It came from that 242 minus 180. And now let's repeat the drill. Let's find the x by using cosine of 62 equals x over 1. Kind of a pattern here. Maybe you're recognizing what the pattern is. So it's 1 times the cosine of 62 cosine 62, 0.469 approximately is our x. And then let's find our y. We've done two of these already, so can we be a bit quicker using Pythagorean theorem perhaps? We'll do hypotenuse squared minus the leg squared that we found, and then square root it. We can maybe do that all in one step. But we're just following the same process as before. 1 squared minus 0.469 squared equals, don't forget the square root, about 0.883. And then we've got it, our point, and we'll add the same blurb since we are in the third quadrant, or I should say in quadrant 3. The point is the following: negative 0.469, negative 0.883. Why both negative? Because we're in the third quadrant where x values are negative and y values are negative. We found the distances using right angle triangle trigonometry. All right, where are we going with this? A little exercise for you guys. So we now know the terminal points, or the point on the unit circle, for 7 different angles. 0, 90, 180, 270, we just talked about. And then we found it for 3 other ones, 45, 150, and 242. If you've already done this to 2, let's just go to 3 to make it match up with our work. And then hopefully you guys see a connection. Can you guys just grind out the cosine and sine for 0, 90, 180, 270, etc., etc.? For the 3U people, you guys have done the cosine and sine of 0 and 90, and you have done 45 and 150, but the others are brand new. These are beyond triangles now. For the 3M people, everything here except cosine 45 is kind of strange because these are all angles, or I guess 90. These are all angles that don't really appear in our right angle triangles. So for 0, cosine of 0 was 1, sine of 0 was 0. Interesting. Cosine of 90 was 0, sine of 90 was 1. As you're populating this table, maybe think back to the terminal, or those points we found, those 7 points we've talked about, and see if you can make a connection there. For 180. Now things are getting a bit weird. 180 is not a possible angle in a triangle, but we still get a value for cosine and sine. Same with 270. Cos 45, sine 45. Not shocking there. 150 has a cosine of negative 0.866. Might be a little strange for the 3M people. We're used to our sines and cosines being positive. And then 0.5 for this one. And then 242. Cosine of 242. Negative 0.469. And then negative 0.883. Did you guys get these as well? Can you guys, maybe while I do my attendance, can you guys compare these values you got on your calculator with the work we've done on the previous couple pages? See if you guys can make the connection. I'll mute my screen. I will pause the recording. But All right. Did any of you guys see the connection? Same number, but let's say, is there a simple rule that we could use? Like, let's say I gave you a brand new angle of 134 degrees, and we don't want to repeat the whole spiel that we just did. You guys see a rule that we can use to get the x value of the point and the y value of the point? So let's look at 0 degrees. 0 degrees, 0 degrees. 0 degrees, point on the unit circle, 1, 0. What was the cosine and sine for 0 degrees? 1 and 0. 90 degrees, the point on the unit circle, 0, 1. What was the cosine and sine of 90 degrees? 0, 1. Let me flip to, let me flip to the last one we just did. 242 degrees, the point on the unit circle, negative 0.469, negative 0.883. What was the cosine and sine? Same numbers, right? So what we have kind of shown here is that all of these angles have a corresponding point on the unit circle, and the relationship is the following. The x value of that point on the unit circle is just the cosine of the angle, and the y value is just the sine of the angle, which is very fascinating that these things are all connected. Popping in this little visual here, I would suggest as well. So we just kind of proved that using 7 different angles. So let's give this new rule a spin. What point in the unit circle corresponds to 134 degrees? Well, according to our new rule, this would be the cosine of 134 degrees and the sine of 134 degrees. We'll just go to 3 decimal places, and then we'll think, do the signs here make sense? Negative 0.695 for the x, and for the sine, 134, 0.719. Did you guys get those two? Does this make sense? Where is 134 in the Cartesian plane? It's between 90 and 180. It's up here in quadrant 2, where x values are negative and y values are positive. It all fits. Can you guys re-emphasize? You already know what 270 is, but does this rule hold? Do the cosine of 270, do the sine of 270. Do we get that point that we talked about the first 5 minutes of the lesson? We do, right? The cosine of 270 gives you 0. The sine of 270 gives you negative 1. Think about 354 degrees. That is almost 360. Almost, but not quite. It's going to have a positive x value and a teeny tiny negative y value, because it's going to be just below the y-axis. When you do cosine and sine of 354, does that check out? Calculator, there it is. You guys are doing great today. So 0.995 and sine 354, yeah, it's teeny tiny negative number, negative 0.105. This is the first of 2 kind of big ideas for today. This is almost the meat and potatoes of today. We can have angles outside of triangles, and they all correspond to a special point on the unit circle where the x is the cosine and the y is the sine. Very neat. So that work we have with SOHCAHTOA led us right here. That's the grand finale. Anything you guys want to chat about? All right, we're going to introduce something called the CAST rule in a second. But we've done sine, we've done tan. What about, we've done sine and we've done cosine. What about the tangent ratio? Is there some third imaginary point that we haven't talked about? No. Let's talk about the tangent ratio right now. So just on the left here, I'm just going to draw out my Cartesian plane. I'm just going to draw a unit circle that is a terribly asymmetrical circle, but you guys can just deal with it. You can do better on yours. And I'm going to draw a little triangle. Theta, hypotenuse 1, x, and y. So I'll let you guys do that too. You guys are doing great. We're doing some heavy lifting today because I'm not here tomorrow. Ms. Plattner's here. It's just going to be a little practice period, an assignment. We just got to get this stuff done today. All right. So what about the tangent ratio? Can you guys follow along here? So from our work from earlier, the cosine of angle theta is equal to adjacent x over hypotenuse 1. So this just shows the x value is the cosine of the angle. Sine theta is equal to the opposite, which is y, over the hypotenuse 1. And this just shows we found out that the y is equal to the sine theta. What about tangent? So tangent is equal to opposite over adjacent. That would be the y side divided by the x side. To get the tangent ratio, you have to, I think we're actually going to stop right there. That is the tangent ratio. It's just the y value over the x value. You actually have to do a bit of work for it, do the y divided by the x. All right, little summary here. For every point on the unit circle, cosine theta is the x value, sine theta is the y value, and tan, from our work above, is the y value divided by the x value. Now you guys have seen, sometimes sine is positive, sometimes it's negative. Same with cosine. Same with tan. Can you guys, for each of these quadrants, little exercise, what would be the sign of cosine, sine, and tan? I'll do the first one with you guys. In quadrant 1, would you guys agree all your x's and y's are positive because you're in quadrant 1, right? That means your cosine is positive and your sine is positive. So we'll just write a plus and a plus. And if the x is positive and the y is positive, what are you guys going to get when you divide y by x? Positive or a negative?
Oh, yeah, I hear you said.
Positive.
You actually
Don't answer. Positive divided by positive is a positive, right? So in our first quadrant for angles between 0 and 90, cosine is positive, sine is positive, tan is positive. What about the second quadrant where our x values are negative, our y values are positive? What will the tan ratio be? Negative. Can you guys do the last two quadrants yourselves? And then we'll take this rule for a spin. Third quadrant, x is cosine. How about I get one of you guys? What's cosine, what's sine, what's tan in the third quadrant? Maybe some of you guys helped out yet today? So in the third quadrant, x's are negative, y's are also negative. What would that make the tangent ratio? Negative divided by negative, the tangent ratio should be positive down there. And then finally, in our fourth quadrant, x values are positive, y values are negative, positive divided by negative is equal to a negative. Let's give this idea a spin, and then I'm going to give you guys a little diagram called the cast rule. So 268, can you guys draw where that angle is? Think about which quadrant it's in, 1, 2, 3, or 4. Make a prediction for sine, cos, and tan. Is it positive? Is it negative? And then actually, on your calculator, do the sine of 268, cosine, and tan, and we'll see if your predictions made sense. I'll give you guys 30 seconds to get a head start on it. Which quadrant are we in, guys, for 268? Flash me a gang sign with the quadrant we're in.
3.
Yes, there you're right, quadrant 3. Now, it's actually pretty close to 270. So something like here, that's all I need you guys to do. That's about where it is. So if we're in the third quadrant, our rule says for quadrant 3, we flip these up here, but sine is negative, cosine is negative, and the tan should be positive. Does that come out when we do it on our calculator? Is the sine of 268 negative? Sine 268 is basically negative 0.999. Yes, it's negative. How about the cosine of 268? It is negative 2, negative 0.035 approximately. Tangent 268, what popped out? Positive, about 28.636. Looks like our rule holds up. Now, can I share with you guys a little teeny tiny little diagram that helps you remember what is positive where? I'm going to tuck it in up here where I have some space. Can you guys just draw this for me? Draw an axis like this. And this is basically the second thing for today. Can you guys write in the letters of cast in this particular order? C-A-S-T. This is called the cast rule. It's like a visual rule. And what is it saying? It is saying in this quadrant 1, this top right quadrant, the A, it stands for all. All of our trig ratios are positive. In our first quadrant, all of our trig ratios are positive. In our second quadrant, up here, which of the 3 is positive up here from our table? If you guys have a look, sine. And so, yeah, there's an S there. There's a T here because in the third quadrant, only tan is positive. And in our fourth quadrant, only cosine is positive. So instead of knowing this whole table, you just write down the cast rule. It's immediate, okay, this is positive in this quadrant, or all are positive, and it's just a nice visual tool. So can you guys refer to the cast rule for this one? First of all, you have to draw 472 degrees. Now, 472 is a 360 and more. Can you guys figure out where you land if you rotate 472 degrees? Is it quadrant 1? Is it quadrant 2? Who can say? Again, doing great, guys. We are going a lot longer than I would usually teach. I personally would hate when my teacher would lecture for 75 minutes, but we just have a lot of stuff to cover today because I'm not here tomorrow. You guys are doing great. So where is this one? So 360 is a full revolution. If you add 90 to that, 450 would get you back to the positive y-axis. Add 90 to that, 540. So that would be too far. Would you guys agree it is somewhere around there? Would you guys agree? Yeah, somewhere around there, right? All right. look at which quadrant it's in, make a prediction which of the three will be positive, which of the three will be negative, and then just crank out those sine and cosine values. Yes, the sine, cosine, and tan of 472 actually has meaning. You will get a value on your calculator. I'll just spin my mouse around for 10 seconds while you guys make your predictions. Using our cast rule. Maybe you even want to write them down. C, A, S, T. We are in the sine quadrant. Sine will be positive. The other two will be negative. And then we're just verifying. Sine of 472, of course, is positive, like we talked about. Cosine of 472 is negative. And the tan of 472 is negative as well, about negative 2.475. That's the cast rule. That's the second big idea for today. When is sine, cosine, and tan positive? You guys okay with the cast rule? Can you guys draw your little cast rule diagram when you need it automatically? It's a really useful thing. All right. Again, I know I sound like a broken record, guys, but I kind of feel bad because I have been doing a lot today. I've been talking a lot today. I can feel it. My voice is going a bit. But again, I'm not here tomorrow. We just need to get this done, and then we can have a day just to consolidate tomorrow. You guys are doing fantastic. In these last two examples, we're going to work with a case where an angle has a terminal arm that's not on the unit circle. Let's look at an example where we have an angle formed by the positive x-axis and a line that ends at the point -8, -5. So -8, -5 on our diagram would be right down here, -8, -5. So part of the curriculum for you guys, for both courses, is to, for any point in the Cartesian plane, find the angle it corresponds to. So we're going to do that here. I'm going to draw a line like that. Would you guys agree, whatever angle this is, it's between 180 and 270, right? It's in that quadrant. It's rotated past 180. The first thing we do with these kind of questions is we find how far that point is from the origin, just the length of this terminal arm, which is actually just using Pythagorean theorem. So we got this, no problem. C squared equals A squared plus B squared. And you can just think of this as a right angle triangle with one side being 8, one side being 5. I'm just using those positive values because on my diagram here, I'm just making a triangle. And we're just finding the length of that terminal arm. It's really just grade 9 stuff. We can do it. I think we'll just do a quick calculation here. It'll be 8 squared plus 5 squared and square root it. And we'll get an approximate value. Eight squared plus 5 squared. Don't forget the square root. 64 plus 25. So that terminal arm corresponding to -8, -5 is about 9.43 units long. The bigger calculation that requires a bit more work is, what's the angle? It's between 180 and 270, but here we just have a triangle, and none of our triangle stuff, we can use angles outside of 184. So I'm going to show you guys how we get this calculation. What we're going to do is, on our triangle here, can you guys label in a little theta, this angle we make with the x-axis? And let's find out what that angle is equal to. We're just using SOHCAHTOA. In that triangle on our diagram, We have the opposite and we have the adjacent. So let's find out this angle. We're just using SOHCAHTOA. Tan of theta, the opposite is 5, the adjacent is 8. We'll do the division. I think that gives you 0.625. And then your calculators will give you the value of this angle we make with the x-axis. So can you guys do that too? So second tan of 0.625. Now I cooked it up. I got 32 degrees, pretty much bang on. You guys get 32? This angle in standard position is clearly not 32, right? It's all the way past 180. It's between 180 and 270. But guys, just have a little think, do some mental math, or do it on your calculator. This angle we have now found is 32 degrees past the negative x-axis. If this is 180 and you go 32 past 180, well, what angle are you at? You can use mental math, use a calculator. In standard position, we're 32 degrees past 180. So if you add those together, the point -8, -5 corresponds to an angle of 212 degrees. How do we get that? We found the angle that it makes with the x-axis using tan, and then used our knowledge of angles in standard position. We're in this quadrant, we're 32 degrees past 180. Arguably, nothing too complicated here. The length is just Pythagorean theorem. You find an angle using tan, and then you use your knowledge of the angles in standard position to find out where we finish at. Here it's 212. You guys are doing great. Can you guys try one more? Draw the point 4, -4. Make a right angle triangle out of it with the x-axis. I'll do it too. Four -4 is right about here. I'll label little c. And this forms a right angle triangle with legs of 4 and 4, because that's the point we're at. I'm using the positive values here. So can you guys find out how far this point is from the origin? That's our length calculation, Pythagorean theorem. Find this angle using the tangent ratio. And then what angle in standard position does this point 4, -4 correspond to? And then we did it. $11.02. Now, as you guys work, I know for a fact there's some teachers, I won't name names, who actually will just talk for 75 minutes. This is the first day I think I've ever talked past 11 o'clock. So we can handle it. Wait till you guys do 3-hour lectures in a year and a few months. All right, I'm going to play catch up here, and we can tie a bow on this lesson. You guys have done great. The length calculation. So I'm just going to do this really quick. It's the root of our two legs squared and added together. The root of 32. About 5.66. All right, and then dial into the diagram, dial into that right angle triangle. We're trying to find theta. The tan of that angle theta is opposite 4 over adjacent, also 4. And what angle has a tan of 1? The three U's should probably know this already, but using our calculators, shift tan of 1, we get 45 degrees. Clearly, this terminal arm doesn't represent 45 degrees. 45 degrees is up here. However, you guys know that the positive x-axis is a full 360, And we're 45 degrees short of that. So what angle is 45 degrees short of 360? You can do the mental math, or in this case, you could show this calculation. Since we're 45 degrees short of 360, well, what angle is that? Just subtract 45 from 360. 315 degrees. The point 4, -4, has a unique angle. It makes, in certain position, 350 degrees. Phew. I'm going to end the video.